ShopPro comes with the microphone system, which has a special system. You can connect the microphone either to I/O box or to the sound card of the computer. Let's select the I/O card option. Connect, and now microphone is connected directly to the channel 0. Make sure ICP power is off because this is regular analog system. Alternatively, you can take the BNC connector off, take the red connector, connect the microphone, banana jack, and take the jack and connect it to sound card of the computer. Now you have an alternative of using the sound card or I/O box. Sound card is of course quite easy if it is operating properly in your computer. Now you take the microphone and bring it close to the machining area. Consider that you collected some machining data using the microphone, and you want to apply ShopDoctor diagnostics module of ShopPro. You start the project again by opening ShopPro. Now we will demonstrate the ShopDoctor, which is a module within ShopPro. We click on ShopDoctor, and here we can collect the sound either using the sound card and the microphone, or microphone can be attached to the I/O box. Alternatively, you can bring the previously recorded sound data. Let's say we are going to measure the sound using microphone attached to the sound card. Then we have two options here to collect the sound during machining. Separated means air cutting and metal cutting sound are recorded separately, or we can combine air cutting and metal cutting as one file. This is quite convenient, especially when the cutting test is not too long. Once we set up the machine, we simply click record button. We conducted milling experiment at 12,500 revolution per minute spindle speed with 5 millimeter depth of cut. We recorded the sound, which is shown here. This part is air cutting, this part is metal cutting. First, we select the air cutting part, which is here. Then we select the metal cutting part, which is this side here. Underneath, we see the spectrum of the sound, and we see a large peak around 2,200 hertz, around that frequency. Now we click on diagnosis. The speed is 12,500. Depth of cut is 5 millimeter. Did we hear a high pitch noise during machining? Yes. Surface finish was really very rough. We were able to notice that. Do you see uneven tool wear or surface finish is good, but these are not applicable for this case? Then we say okay. Then the diagnosis indicates the following. Chatter is detected at 2,202 hertz, and it recommends us to try cutting experiment at around 15,237 RPM, which is this point, still 5 millimeter depth of cut, or reduce the cutting speed to 10,731 revolution per minute with the same depth of cut. Well, the third option is to reduce the depth of cut so we can remain under the stability lobe. Now we will switch to this point and conduct cutting experiment at around 15,000 revolution per minute to see whether chatter disappears or not. We conducted milling tests at 15,000 revolution per minute with 5 millimeter depth of cut, and we did not hear any chatter. And if we look at the air cutting here, this zone, we select the air cutting first. This is the air cutting, and we go to metal cutting. We select the metal cutting zone. Then we apply diagnosis, and we enter the spindle speed of 15,000 revolution per minute. Depth of cut is 5 millimeter. Maximum spindle speed on this machine is 20,000 revolution per minute. We did not hear any high-pitched noise during machining. Surface finish was good. And the other two are not related. Say okay. And no problem could be found in the process because we are in this stability lobe and there was no chatter. ShopPro has built-in automated report generation system as well. If you click print preview here, the software will ask you the graphs that you want to include in the report. Let's say we want to include all of them, and you click print preview, and here is all the measurements. This is hammer test, stability lobe, power and torque curves, the sound measurement in metal cutting and air cutting, and so on. It continues. And here is the last cutting condition we had. In order to avoid, for example, force vibrations, we look at this point, we look at the hammer data, we make sure that the speed does not coincide with one of these frequency peaks. Thank you.